Good afternoon, everyone. Welcome to the graveyard shift for the ops track. Hopefully you'll find this useful for the end of the day. We'll try not to keep you from the reception for too long. But we're going to go through some, I think, what are interesting cases that we at Seenit, and hopefully some of you will have seen my talk earlier about what we're doing. So if you don't know who I am, I'm Dave Starling. I'm the CTO at Seenit. We're a startup based in London. And I'm happy to be joined by Anil, who's a product manager for a Google Cloud platform. So we're gonna basically talk to you guys about our journey, the Seenit journey, but how Couchbase and Google Cloud platform have helped us along that journey as a small startup with few resources, few people within our organization. And Anil's going to talk about how some of the advancements that they've been working on with regards to machine learning and the Google Cloud platform itself, and how that's impacting startups like us and giving the capabilities for us to do some amazing things. So I won't go into too much detail on this because it's not very exciting, but Seenit's a startup that was founded in 2014. I joined soon after it was founded. And I had the opportunity at that point to define the architecture from ground zero, from absolutely nothing existing to where we are today. And I'd done that on the back of coming from a media organization that organized a lot of photography and video content from around the globe at theme parks. And I had some experience with Couchbase. So what Seenit was starting to do was look at changing the way that large organizations think about creating video, specifically crowdsourced video from mobile phones, and allowing them to tell interesting stories using either their fans, their consumers, or their employees. Technically, we run with Python. Almost 99% of our code is Python. CherryPy is our web framework of choice. And we run a lot of RabbitMQ within Google Cloud as well to give us very large parallel processing on asynchronous task queue. So if we're dealing with video, we don't want to be doing a lot of synchronous processing and waiting for things to happen. We just send them off, we scale out, we scale elastically, and there's some really nice features within Google Cloud that means we can do that cost effectively as well. So when we started looking back in 2014 about what we wanted to build as a platform, we came up with a list of definitions of requirements that we had for our database and our cloud provider. Both of those overlapped heavily, not just in terms of looking at what our cloud provider could do as a pure VM capability. So we didn't just want a cloud provider that would provide great, we can spin up VMs. So we wanted a cloud provider that would add value to us as a consumer. So our first one was global scale. It's a word you've probably heard a lot today. For us, what that means is we want to make sure that all of our clients, so our clients are typically large enterprises, either within an organization, so HSBC, they operate within 70 different countries, 250,000 employees, all using our platform. How can we make sure that every single one of those countries gets a good quality user experience? And how can we make sure that those user experiences are consistently solid and grow as we grow as a company? So global scale was a really big one. Schema agility. So we were defining a product from nothing. We were defining a market that didn't exist within the video space, and we knew that there were features that we were going to be building that didn't, that weren't necessarily going to work, or we needed to tweak them very quickly. And at the time, I was the sole platform developer as well, so I wanted to make sure that I wasn't having to manage infrastructure that was, we were going to have to handle schema changes and rollback capabilities, and all of the stuff that I've tried to put back in the 2000s. JSON. So we have a mobile app, we have a web app. We wanted everything to speak at the same common language. The APIs that we speak with, especially on the Google machine learning side, didn't exist so much back then, but we knew that JSON was going to stick around for a long time as a standardized way of our systems communicating with each other, whether that was RabbitMQ and we just send JSON payloads across as a message, or just all of our APIs in a very nice RESTful manner. So we needed something that spoke JSON. Performance, I mean, some of these are kind of no-brainers in terms of, well, of course I want a high-performing database. But, again, we're dealing with large enterprises who require SLAs, and we need to be able to deliver consistent performance across the globe. And, you can't say, okay, performance doesn't matter to me. Resilience, again, with the types of clients that we have mean that we need to be able to operate consistently across the globe. We need to be able to handle downtime. We needed to be able to handle, things go wrong. The cloud architecture is always built from the perspective of stuff happens. Things will break. How do you handle that in a resilient way? How do you handle that gracefully? So we wanted something that we knew would handle that. Support, and I don't just mean support like as in ticketing support, or something's gone wrong, I'm going to get a ticket. What I mean by support is, do we feel engaged with the community, the product teams, the engineering teams, is the community manager someone that we would happily go out for dinner with and say, this is really exciting, but I think we could do this. And the same with the product team. So not, as a startup, the support that we get from organizations like Google, like Couchbase, we think were really important to us. So we wanted to make sure that we could take the experience of a large organization like Google or like Couchbase and basically stand on the shoulder of giants and do lots and lots of things that we would not ordinarily be able to do with the resources that we had. Cost, as a startup, that's going to be massively key. We need to be able to run operationally efficiently with minimal cash spend for us. Security, so we deal with financial institutions, military contractors, the organizations that we were focusing on as markets in where we were starting. We're dealing with commercially sensitive information, so security has been key for us throughout those throughout the 3 years. It still is. It's the biggest blocker in our whole procurement cycle. The time it takes for us to go through security auditing is quite painful. And I think last but definitely not least is we didn't want to have a platform that we were going to invest in that was going to be stale. So we didn't want to have a database that was just going to be a database and then we had to build all of the additional features on top of that. We didn't want to have to say, okay, we've got this data, how do we search it? Oh great, we're going to go and find a search engine and plug that in some way. We wanted to have a database and a cloud provider that we thought were going to push the boundaries. And so what I'm going to do now is go through each of those against Couchbase and Google and just basically tick them off. So why Couchbase? So global scale. I think you've probably seen in a lot of the talks today and Matt's talk in the keynote this morning, global scale is very easily done with Couchbase. You can fire up a cluster of nodes within a data center, have XDCR in multiple other data centers, and you have global scale. It's quite simple. Schema agility. Yes, it's the biggest selling point of Google of Couchbase. It's the biggest selling point of what a lot of the developers will be evangelizing about what Couchbase does for them. JSON, yes, it's a JSON store. Performance, we'd seen from the talks about how other people were using Couchbase, and I'd known from previous experience about what the performance metrics were. We knew it could scale horizontally very easily. At the time, Nickel didn't exist, so we were doing either a lot of MapReduce views or we were using a lot of manual global secondary indexes, but nevertheless the performance was still there. The resilience is there by the nature of the clustering of it, the ability to fail over rapidly, and we didn't have any problems with that at all. The support, I think, that we're at an event here today with some great speakers from the Couchbase team, shows the level of support they're willing to engage with you. You know, they'll happily go and have a coffee with you or a beer with you and talk about what they're doing, what's exciting coming up. The cost. It's not a cheap solution if you're an enterprise customer, but you get what you pay for. So the cost of any database is never going to be the smallest part of your budget, but at the same time, you're not paying Oracle level fees. You're not paying, you know, tens of thousands of pounds for a license that you can never get out of. You pay per node, it works very well. You basically pay for what you use, which is a very cloud type model. You're paying for only what you need. Security, that's definitely something that's been improved over time. It was secure, but now with things like role-based access control, X509 and so on, you know, that's definitely got solid grounding in what we need, and all of our security audits that we've had done by third parties has been quite solid. And the aggressive feature development. So I think, again, the amount of effort that we've seen from the Couchbase team in the terms of what they've been able to develop over the 3 years that we've been using it, it's gone from, like, you know, a very basic MapReduce JSON store to having a query engine, an indexing engine, full text search, cross data center replication, XDCR with filtering, mobile. You know, everything shows that we're having a lot of aggressive feature development within the Couchbase ecosystem. So all of that means that I have a nice happy face. And then, why Google Cloud Platform? So again, global scale. They have a number of data centers around the world. It's growing more and more. So I think, what's the latest one that's launched? Singapore?
Singapore, Japan.
Yeah, I think London's coming this year and a few others. Schema readability and JSON, not so much. They, in the sense of the schema readability, in the sense of the machine learning APIs we work with, plug very much into the schema readability that we have. So I'll give that a tick, but you know, it's a grudging tick. But JSON, definitely. JSON, all of our APIs are JSON based. We'll talk more about the machine learning APIs, but we don't do any processing on those. We just take them straight from the API and dump them straight into Couchbase. So that works very, very well. Performance was the biggest differentiator for us when we compared it to the competition. So the types of distributed load that we were doing with large video binary objects coming from Google Cloud Storage, which is their equivalent of Amazon S3 if you come from an Amazon world. I'd come from an AWS world myself, and we did some very simple benchmarking of the types of load that we were doing. And because Google had been basically building their own infrastructure from the beginning, their own networking, they've got their own fiber lines across the Atlantic and I think the Pacific as well. The performance was pretty much double what we were getting the same on Amazon or Azure. So we were more than happy with that, and actually that was probably the biggest tick box for us in terms of choosing Google Cloud Platform. Resilience, yes, it's a cloud platform. You have to have resilience in there. I'm not going to dwell on that. Support. So again, this was another differentiator we found when we compared with Amazon. To get in front of a solution architect at Amazon, or to get in front of product engineers at Amazon, in my experience, we found that the dollar spend you had to have was very high to get in front of anybody who could actually give you any information or give you some guidance. I think that's changed a bit over time since then, but that was definitely the experience we had back in 2014. The Google team, I think, had a much more grassroots level approach, and they knew that they needed to approach startups to say, like, okay, we're doing some cool stuff, you can do it on our platform, and we're going to engage with you. And we found a very engaging product team. Even as a small team, we've had trusted tester access to a lot of the APIs, some of which aren't even announced yet, where we're under a strict NDA, but they sort of say, well, we think your use case is actually really exciting, so we're going to let you have access to this and feed back into the product team. So that was really important to us. Cost. we were lucky enough to be part of an accelerator as well. We applied through a startup program with Google. We got a bunch of free credits, so that definitely lasted us for probably 6 months or almost a year, I think. But again, that gave us a real ability to prove ourselves as a product and as a company at that point. Security, cloud security is a question that I always get asked when we're talking to CIOs or cybersecurity folks at banks and financial institutions. And then all I do is just point them to the compliance page on the cloud platform site and just say, look, there's ISO 27001, SOC 2, SOC 3, everything you would want to know. Basically, do you trust me to run a data center or do you trust Google? Because I don't trust myself to run a data center. And so I think I'd much rather let people who know what they're doing do it. Aggressive feature development, again, very similar. They were doing a lot of cool stuff that was driven by the fact that they had this huge amount of infrastructure in place, but not a huge level of software development in place. So the platform 3 years ago with Google was relatively immature when it came to the software capability. So there was no equivalent to Amazon's CloudFormation. Now there is. There wasn't container support back then. There wasn't a lot of machine learning capabilities back then. Now there all is. So we knew that, again, we were going to be able to take the expertise of the guys at Google and apply our own domain knowledge on top of that, and really then get a much better process of working than we would be able to do with the limited resources that we had. So, smiley face from me. So how do they work together? So this is some practical, what do we actually run in production? We're still a relatively small outfit. So we run 8 production nodes, all on Google Compute. So Google Compute is the EC2 equivalent, again, if you come from the AWS world. You could run it on Docker and Kubernetes and do it that way if you want, but there are reasons why we went with Compute. So multi-dimensional scaling gives us the ability to have very strong performance efficiency. So by performance efficiency, I'm talking about how much cost, what is our return on investment on how much we're having to spend for the performance we're getting. And so there are two factors here at play. One is the ability for multi-dimensional scaling within Couchbase to work very well, and the second is the way the machine types in Google Cloud Platform work. So rather than being constrained to specific node types, so rather than being able to say, okay, you can have an 8-core machine, but with an 8-core machine, you can only have 16 gigabytes of RAM. Now you can do a lot more with custom machine types, where you can say, okay, I want 5 cores or 6 cores, but I want 32 gigabytes of RAM or 178 gigabytes of RAM or whatever you want for your use case. And that becomes a very compelling argument to say, like, okay, now we can run multi-dimensional scaling, but actually I can be very memory focused, and as an in-memory data store, that's going to be much better for me, and I don't really care about CPU as much. The custom machine types actually is a relatively new thing, right? But it's been very good for us to save on costs. So we run 4 data nodes, and then we run 3 index query nodes. Again, custom machine types, high CPUs. All of our machines use SSDs attached to them. For our video processing and transcoding machines, we're actually now starting to use attached GPUs. So there are NVIDIA Tesla devices attached on there. So you can do some really interesting things with that. If you're doing any matrix manipulation or running any strong mathematical processing. And then recently we added a single FTS node. So FTS is still in developer preview. We wanted to separate it out from our core production nodes just in case, but we knew that if we had a single FTS node, then it would be pretty safe to run on there. What we then do as a practical thing is to be able to rapidly scale up and be elastic. We actually will image our servers. So we have a base image, and that is pre-hardened. So all of the stuff you would do for hardening your Linux deployments, and then we then take an image of that disk, which means we can fire up a new instance very, very quickly, typically within a few seconds. We do this with all of our machine types and all of our deployments. Our Jenkins builds basically build through the Google APIs. We will build a machine, install everything on it, and then kill that machine, create an image from the disk, and then that becomes our deployment mechanism. It means that we're front-loading the build process, so we're not doing runtime deployments, so we're not using Chef or Puppet at runtime to build those machines. And what that means is that when we're scaling out elastically to react to load, we do that in a matter of less than 10 seconds, rather than having to go through perhaps a difficult and long build process. From backup, we do a number of backup processes. All of the data is stored on attached disks, and those are snapshotted nightly. But we also then have a nightly, actually hourly CB backup to Google Cloud Storage. So it's just a little Python script that does that. And then we also have, in an alternative Google Cloud data center, a disaster recovery cluster using XDCR. So we can recover very quickly with a hot standby. So here's what our architecture looks like from a scale-out analysis, media analysis perspective. So we have our ingestion, we have our task queues running on Google Cloud Compute using RabbitMQ. Those pipeline workers, they're basically compute workers. We analyze the queue depth, and we'll fire up more machines depending on what the queue depth is. The way the auto-scaling in Google Cloud Platform works is you can either do it by balancing CPU load or some other metric across your cluster, or you can have a custom metric that you make available and then scale up on that. And then all of that content is then stored either in Google Cloud Storage if it's binary, or Couchbase if it's metadata, text, non-binary JSON data. So how have we scaled over time? So 2014, we were still proving MVP. We were building our platform, working out what we needed to do, how did it work. Nickel didn't exist at that point anyway, so we had 3 data nodes, the bare minimum you need to run a resilient Couchbase cluster. 2015 to 2016, gradually added more data nodes, then multiple query and index nodes when Nickel was released, and then dedicated FTS nodes. And then we also have development and continuous integration test and security test clusters as well, which mirror production, not from a data perspective, but just from a cluster distribution perspective. So what challenges did we have? So fortunately not too many, but there are some practical ones that gave us some headaches to start with. So if you've used Amazon EC2 before, you'll be aware that they have a nice DNS capability where it's a CNAME that you can point to, where if you're internal, you will get the internal DNS. If you're external, you will get the external DNS resolution and the IP address for the external IP. GC doesn't have that. I've requested it, and Anil is very kindly going to push that forward for me. But that's a challenge we had. We got around that through just using host files. A kind of a quick and dirty hack, but it works quite well. It starts to get more complicated as you add more capability, but you know it's part of the nature of development. Debian 8, we were running Debian 8 for security reasons over Debian 7. It took a little while for Couchbase to release Debian 8 compatible images. We got there, but that was a little struggle for a while. Test and development clusters, not a challenge in the sense of it's a problem, but it's something you need to deal with. So what you can do now is once you've got these images, you can create through Deployment Manager, which is your infrastructure as code system within Google Cloud Platform. You just define a YAML file or a JSON document to say, here is what my structure should look like, fire this all up. And it's a really good way of just defining a whole structure of your platform. So now we're starting to replicate our platform in other regions for data sovereignty reasons. So that is our deployment mechanism for that. Rolling upgrades, how do we handle rolling upgrades with Couchbase? Right now, we do it by just handling some downtime. Typically, it's just a case of running the Debian package manager, and then it does what it needs to do, but we'll do that as part of a downtime maintenance block. If we were to do it where we didn't have any downtime, we would probably just fire up another cluster XDCR over to it, swap that over on the software side, and then flip back. So all of our software deployments typically are A/B stack and then swapped at the load balancer. We would do a similar thing with the database cluster. So now for sort of a bit more of the fun stuff. So Google machine learning in Couchbase, and Anil's going to talk a lot more in detail about this. So Google have really gone in very hard on machine learning. Everything they do is pretty much AI or machine learning driven, and they're starting to open a lot of that up now. So we use, and I can see my slides are slightly out of order here, but bear with me. So we wanted something that would talk JSON, store JSON, and search JSON. And we knew that a machine learning platform that did all of that would integrate very nicely into our Couchbase system. So we were starting to look at last year using computer vision, using Google's machine learning platform, which is all powered by Tensorflow. So Tensorflow is an open source machine learning platform that you can download, run on your home PC. If you've got a graphics card, like a nice GPU, you can use as well to accelerate that. But you can also use CloudML, which is the managed service. There are several ready-to-use tools you can use with this. So video, which was just announced, is in, I think, is it still alpha? I think it's still alpha. Not quite beta yet. Vision, which is GA. Speech just went GA, and natural language, I think it's going GA soon. So all of these things allow you to do a lot of manipulation and extract a lot of really interesting data about some of the objects you might have. And we've got that fully integrated with Couchbase, especially using full text search, but also Nickel. And that allows us to then search and extract intelligence and provide value to our customers very easily. It's a fully managed service, so we don't need to build and run our own hardware. So this is, your serverless architecture, which is the very trendy way of putting it nowadays. But you've got a fully managed service; you don't need to worry about that. You also get the advantage of the custom hardware that Google's starting to invest in with their TPUs, which are the Tensorflow processing units, which allow it to run extremely fast. So you can get more detail at tensorflow.org and then cloud.google.com/ml. I'm now going to switch over, hopefully, to Anil's slides, and then we'll go into a little bit more detail about the machine learning piece. Well?
Yeah, thanks, Dave. So I thought I'd give you a quick introduction on Google Cloud Platform, how we think about cloud, and then jump into some fun stuff around machine learning, which Dave's using in production, which is always exciting. So you can see real use cases. I think the first thing is to understand Google's approach to cloud. Google's been a cloud company for a while because we have so many services that service over 1 billion customers. I think we have 7 of them listed here. And the only way to do that is to have basically a cloud. What we've done is we've brought that to our end users. And so all of that hardware, software, network operations, data center management, all of the infrastructure that Google's invested in for so many years is now being made available to all of our customers, which is really exciting. And so it's going to give you a snapshot of where we're at today and kind of our planned rollout in terms of compute regions around the world. You can see pretty much a global footprint. And that's supported by a very, very extensive network backbone. So when you think about YouTube videos and all that traffic flying, those are some of the same infrastructures we're exposing to our customers. So all that investment we're doing throughout our company is being made available in our cloud platform directly. And so this kind of gets into some of the interesting details. Some of the highlights that I like to talk about are 1 million QPS with no pre-warning. Like, there's just mind-boggling numbers just at Google scale, and the fact that we have all of these edge locations in every country. And this mostly shows the intercontinental backbones, but the fact that we have edge presence in pretty much every country is fantastic as well. In terms of how do you do this? Well, you spend a lot of money. $30 billion over the last 3 years. $30 billion. That's just capital expenditure. So it's a really serious business. It's not for everyone, but the results show, and I think that's why we have great customers like Seenit being able to take advantage of it. this kind of goes over the breadth of the Google Cloud Platform services. I won't talk through all of these. Kind of key takeaways is we have your usual suspects, right? Whether it's compute, big data, networking, storage, machine learning, developer tools, management tools. It's really an extensive platform. It's not just for ML or not just for compute or not just for storage, but it's really the whole package, and all of these work well together at the API level. What I want to talk to you today about is kind of go deeper a bit on the machine learning, kind of keeping with the same theme from Seenit's presentation. How many of you are using machine learning in some fashion today? Okay, not many. So, so pretty interesting statistics around data and how much data actually goes unused or untapped. So unstructured data is about 90% of enterprise data today. And all of that's kind of just sitting there without much analysis because there's no tools really to go in and understand what's going on. And this is one of the opportunities we see machine learning playing a big role in, because machine learning can actually come in and make sense of it for you. But to do that, you sort of need three things. You need to obviously have the large data sets that you can use to train good models. And you need a lot of computation to be able to churn all that data through those models and retain and actually make sense of what's going on. And so this problem naturally lends itself to cloud, because you often are not training all day, every day, 24/7. And so it's kind of a bursty workload. And you might have models that you've custom created, or you might want to use models that pre-exist. And that's really where Google Cloud Platform and machine learning come in. We have several pre-built models. Dave mentioned some of them they were using themselves. They're fully pre-trained, and this is taking advantage of Google's expertise. How many of you use Google Photos today? So all of the insights and smarts you're seeing in the Google Photos application is actually built on these APIs that you also have access to. So it's really this kind of journey of Google innovating, sharing that innovation out in the form of an API, and then great companies like Seenit being able to build on top of that. But sometimes we don't solve everything, and that's where you can bring your own models. And that's an important part of our story as well, right? Machine learning isn't restricted. You can build your own domain-specific models, and you can use Google tools to train and continue using them, all with the same set of APIs. So I'm going to give you kind of a brief tour of some of the big, interesting APIs we have around machine learning. So this is around Cloud Vision, and this allows you to take photos or videos and actually understand what's going on. So we actually have a cool demo of this. Just briefly, it covers a wide variety of topics. There we go.
Yeah. Check
Cool.
the
Yeah.
resolution. Good. There you go.
So this is a pretty cool demo. So what I can do here is we've ingested, I don't know how many hundreds of thousands of photos here. We've kind of created a word cloud of all of these photos we've ingested. And what it allows me to do is click through, and let's say I want to look at some photos of nature. It's not letting me click for some reason.
Oh. That's weird. Refresh. Copy the resolution. Thinks it's.
Okay, we'll just use these on the side then.
Yeah.
Okay, so I'm not sure what's going on there. So here we have an example of photos that were ingested, and the Vision API giving us a peek into what it thinks the photos are. And so what you end up with is a ranked and scored list of topics. So in this case, it's saying, with a certain confidence interval, it thinks it's a sign, thinks it's for a road, and it thinks it's most likely a traffic sign. It's pretty sure it's yellow. It's pretty sure it's also a street sign. There might be some wildlife. So it's a fun tool. You can play around with it, and it's pretty fun because it works in different languages. Here we have a street in India, and it recognizes and has been trained on similar data. There's all sorts of fun stuff buried in this demo, but it just kind of gives you a peek of the kinds of data that Google's trained on and the kinds of benefits you get just right out of the box using the platform APIs with no training involved. And so whether it's a photo of a plant, here it says there's a flower, this color, it's a plant, it's orange, it's a flowering plant, it's a close-up. And so really whatever kind of application you're trying to build, there is an exhaustive set of data just waiting for you. And obviously we've visualized it here, but all of this is available in convenient JSON ready to store in your Couchbase database. Scroll over to the side.
I'm going to go to something else.
Okay. So yeah, so the Cloud Vision API gives you several things. One is face detection, logo identification. If they're brands, it'll actually bring those up. Labels, like we talked about, animals, flowers, nature, etc. Another important use case is, especially when you're dealing with user-generated content, is you might want to understand if there's any explicit content in those files. You can actually detect them, and you can take action on them. OCR, or text translation, is built in as well, and landmark identification. Video intelligence is also interesting. So imagine taking the same set of APIs that work on raw frames, but now applying it to video streams, and then being able to take a video stream and figure out in what kind of time slices are various tags present. It's a very powerful way of quickly understanding or getting to a particular part of a video stream. If it's user-generated content, for example, you might be interested in a particular area where you only have faces or not faces. So you can quickly kind of hone in on the area that you care about. Cloud speech related, Google obviously has a huge investment in speech technologies from Android and other products, and those similar APIs are available directly to you. This extends to speech to text, and then also the translations and conversions between languages. Natural language is sort of the next logical step. So you've spoken something, you've got it down into words, but now you're trying to make sense of those words. And so here's a sentence that maybe was translated from the speech API. But what the natural language API is able to do is kind of hone in on the key words that actually have some context, and will actually describe what that context is. So here it's telling me that Google's an organization. There's a place called Mountain View. There's an event called the Consumer Electronics Show. There's a person named Sundar, who's our CEO. And there's something called Android, which is a consumer good. So it's been trained on this large corpus to understand these insights, like, for example, iconic folks. So you can pick those up. And again, all of this available via our APIs in JSON form. Of course, you can bring your own data. So this is a big key part of any cloud project, is you have a massive data, sometimes multiple data sources. And the key thing here is that data can be stored in Couchbase, in cloud storage, in BigQuery, in a variety of products, but they can all use our API and leverage our cloud. As Dave mentioned, our machine learning technologies are built on Tensorflow, which is actually an open source project. And that's another key part of Google's contribution in this area, is we want to build in the open. We really believe in AI as a future, AI being kind of an AI-driven company at some point. And Tensorflow is kind of the flagship project around this. The number of contributors is outstanding. It's like 10,000 commits in the last year. It's just pretty, just amazing growth of this project. And what's really fascinating about Tensorflow is not only does it work in cloud or CPUs, but also supports GPUs. And that's where we really start to see the accelerated training happening. And on Google's side, we, as Dave mentioned, take advantage of GPUs. So we have specific TensorFlow optimized processing units that help us execute TensorFlow models faster than just on the CPU or any GPU. And we've been using these in production for over a year. So really well tested. You can trust that if Google's using it, it's something you could probably take advantage of as well. So a couple of kind of interesting examples that I enjoy sharing just to kind of cap this off. Here's an example of where you have satellite imagery and you're trying to detect whether the image being shown has some clouds or not. And if you imagine a satellite taking pictures of terrain, you want to make sure that there are no clouds present, because if there were, then obviously they're going to kind of occlude what you're trying to look for. So when you're dealing with tons and tons of data coming through these satellite links, you want to be able to quickly sort out and figure out which geographies you need to retake images for in case there were clouds. And traditionally, this was maybe been a manual process where someone has to go in and actually see is there a cloud or not. But you can actually train a machine learning model to discover the same. And it actually turns out to be a pretty tricky problem, because clouds and and snow tend to look quite similar. But by training a machine learning model, we're actually able to reduce the error rates from 11 to 3%. So just kind of interesting little ways where machine learning can really, really save you costs, save you money, save you time, and actually give you more accurate data. Another quick example I like is being able to use the vision APIs and machine learning capabilities actually proved that there was illegal fishing happening in a certain part of the world. And so it's not just for consumer goods. You can actually use it for NGOs or to kind of keep an eye on what's actually happening in the world. And so by training these models, using the APIs, taking advantage of the advanced computing power that Google offers, you can actually build these real-world examples in kind of no time at all. And this one, I think, led to a pretty significant fine. So maybe the project paid for itself pretty quickly. So I'll kind of cap with this slide. All of these demos are available for you to try yourself. And of course, you're welcome to use the products as well. If you're new to Google Cloud, we offer trial credits. You get $300 over a year. And see me afterwards if you have any questions. Thank you.